First, we're going to discuss the different options that we have when importing our model from external files. And to do this, I'm going to show the different options using a simple Caesar2 file. The Caesar2 file that I've made for this looks like this. It's a 4-inch pipe. Different elements are defined. There's a valve, and there are restraints on the end. So there's an anchor restraint on one end and a rest guide on the other end. And then the straight sections of piping have intermediate nodes. So in this case, the intermediate nodes for this pipe section are node 20 and 50. So I'll open BOSfluids, start a new job. I'll call it importing 1. And then in the BOSfluids interface, we can go to File, Import to start importing our models. If we select File Type, we'll have a list of all the different file types that can be imported into BOSfluids. So there are 3 different types for BOSfluids itself. There's the Caesar2 neutral file, Caesar2 structural files. There's a piping component file or PCF file, which we'll cover in more detail later. There's a pipe profile file, which is a comma separated value format for pipe profiles. And there's an epanet file. And finally, we can also import BOSpulse files into BOSfluids. I will browse for the file that I want to import, and I've already created a Caesar2 neutral file from the Caesar model that I've showed you before. Then under Action, there are 3 options, which when we're importing a model into an empty file, these options don't matter, but we'll cover them a little bit later as well. Now, when we have selected that, we'll have some import options for the Caesar2 neutral file. The first is to merge elements. So as I showed before, the Caesar model has some straight sections where the properties of the pipe do not change, but there are intermediate nodes. And for our flow model, these intermediate nodes are not strictly necessary. So if we select the merge elements option, these 3 elements, so between node number 10 and node number 60, will be merged into a single element, which might be easier to work with, to have less elements within our model. For now, I will turn this option off. Optimize bands can be used to, as it says, optimize bands, and it's mainly important for when you're working with miter bands in Caesar, in which case there might be small elements around the band defined, which BOSfluids will try to merge as much as possible in order to make a band that can be handled by the flow solver. The keep rigids option, if we compare again the Caesar model, if we have this checked, then this valve will be also imported into the BOSfluids geometry, and we can uncheck this, and then this valve will be modeled as a straight pipe section. Then import restraints. Well, fairly straightforward. At node number 10 and node number 90, we have different restraint types, and we can choose to import them or not. Finally, C-nodes. Caesar uses something called C-nodes, with which you can connect different elements together by means of certain restraints. And if you select merge C-nodes, then the C-noded number and the node number that are connected will be merged into a single node number, so that in our flow model in BOSfluids, we'll be able to have flow going through those connections as well. So if you leave this unchecked and you have connected different parts of your stress model through C-nodes, then it's possible that for the flow model, it will consist of unconnected elements. Here in the bottom we have option to import different structural files. If we have those available, we can also import them directly. Press OK, and we'll see the imported geometry. We can turn on show labels to see that also the node numbering is the same as it was in the Caesar model. We can see that the diameter and the thickness have been taken from the imported file. Now it could of course happen that the stress analysis team has decided that they want to make a little update to our model, but we've already set up our analysis in this file. So to illustrate that, I'm going to apply some flow boundary conditions. We'll put a fixed flow on one end. And on the other node we'll put a fixed pressure. And now we want to update the geometry, the model that we currently have. So we can go to import, and we'll select the updated file, file number 2. And now under action we have 3 different options: to replace the model, update the geometry, and extend the model. When we replace the model, all the different elements that are currently in our BOSfluids file will be removed, and the new elements from the new file that we've just selected will be added to the model. When we choose update geometry, BOSfluids will try to keep as much as possible the flow elements while updating the geometry of the piping with the piping that is in the new file. It'll try to do that based on the node numbering of the current nodes and the nodes that you're importing. And the third option, extend model, will add all the elements in the new file to the current file, and all the elements that are already there will be kept. This might cause some clashes in node numbers. For example, all the files or all the elements in the simple line 2 file also have nodes between 10 and 90. In that case, the node numbers will be increased in order not to cause any clashes. So we'll once again turn off the merge elements and press OK. Now we have an option to merge the nodes, which I'll turn off so that we can get the 2 different models, so we can see them side by side. And a warning message will pop up about the node identifier collision. So that's indeed, as I said before, the nodes of the 2 imported piping models are the same, and so the new file has been the nodes in the new file have been increased by 1,000 in order to prevent any clashes. And the same is true for an element identifier. So there was an element that has the name valve in both. So one of them has been renamed to valve with the numerical postfix. So this is the new model that we've imported. If we go to the coordinate mode, then we can click left click to read the coordinates, but also right click to edit the coordinates. So we can move it a little bit out of the way so that they don't overlap anymore. So if we were to update the geometry, we would like this bend to be included. But as you can see, the new model doesn't include the valve, and it doesn't include the different the different flow boundary conditions that we've defined. But we can use the update geometry option for that. So now I'll import again the simple line 2, but instead of extending the model, I'll choose update geometry. And since the node numbers match with this line that we've had before, when I import this, we'll see an updated geometry that includes the piping geometry of the simple model 2 with the flow elements that were defined in the model before importing it. So we have our boundary conditions, we have our valves, we have restraints, but we have the geometry of the new model.